Hello children, welcome back to my channel. The chapter is Quadrilaterals of standard 9 and this is part 13. So, we have been doing questions related to the midpoint theorem. Hope you would have practiced the problems and the theorem we just discussed in the last two parts. Now, here the question is given ABCD is a kite. So, what is the property of a kite? The adjacent angles AB will be equal to AD and BC will be equal to DC. It is not a parallelogram because the sides are not, or the opposite sides are not parallel. It is only the adjacent sides AB and AD are equal and BC and DC are equal. Now, you and P and given PQ, R and S are midpoints. Now, you have to prove PQRS is a parallelogram. Okay. Sorry, PQRS is a rectangle. So, the first thing you have to prove PQRS is a parallelogram. The proof you can refer from my earlier video. So, for all the questions like this, the first step will be you have to prove the PQRS is a parallelogram. Okay. Now, you have to show it is a rectangle. To show it is a rectangle, I have earlier also mentioned you have to show the vertices, one of the vertices 90. So, suppose if you are able to show P is 90, then parallelogram, one of the angle is 90, it is a rectangle. So, for that we have to use the property in a kite, the longer diagonal bisects the smaller diagonal at right angles. So, that means AC is parallel to BD. So, this is 90. This is the property of the kite related to the diagonals. So, to prove that, this also we have done in one of the earlier question, you have to prove PXOY is a parallelogram. So, to prove that, consider the triangle ABC. PS is parallel to AC. The reason is P and S are midpoints, midpoint theorem. Similarly, consider the triangle ADC, QR. PS is parallel to AC, so that you can write before we proceed. PS is parallel to AC, so you can say PY is parallel to OX. PY is parallel to OX. Similarly, consider the triangle. Now, you have to PY you have proved is parallel to OX. Now, you have to prove PX is parallel to OY. For that, you will consider the triangle ABD. PQ is parallel to BD. The reason is again P and Q midpoint theorem. So, PQ is parallel to BD means you can say PX is parallel to OY. Therefore, so from 1 and 2 you can say PXOY is a parallelogram. Now, you will use the property AOB angle AOB equal to 90 degrees. You will write the above reason which I have already mentioned this starting. So therefore, now we have already proved PXOY is a parallelogram. Now angle O is 90, this is 90. So the opposite angles are equal. Therefore angle P, that is YPX or XPY, equal to 90. Opposite angles are equal. So in a parallelogram, one angle is 90, then it is a rectangle. So the next question, given it is ABCD is a parallelogram, E and F are midpoints. You have to prove AF and CE trisect BD. Trisect means dividing into 3 equal parts. So you have to prove BP is equal to PQ is equal to QD. So to prove that, if you consider the triangle AQB, you have to prove BP equal to PQ. That is, P is the midpoint of BQ is what you have to prove. You have E as the midpoint is given. To prove P as the midpoint, you need one more data, that is EP is parallel to AQ, which we do not have. So now our purpose is, now we have to find out how you can show PE is parallel to AQ. Similarly, you have to prove QF is parallel to PC. Then we will be able to prove BP equal to PQ and PQ equal to QD. So we will start. AB is equal to CD. Now, because opposite sides are equal, ABCD is a parallelogram. Half of AB equal to half of CD. We will write the reason also later. Let us finish these steps. So half of AB I can write it as AE equal to CF. Then we know AB is parallel to CD. So we can say AE is parallel to FC. So the reasons, so this is 1 and this is 2. The reasons for this is opposite sides are parallel and equal. So AE is parallel to FC and AE equal to FC. That is, you got these two are equal. That is, you got these and this is parallel and equal. Therefore, it will be a parallelogram. Therefore, AECF is a parallelogram. Then you can say AF equal to CE. Sorry, AF is parallel to CE. We need parallel. AF is parallel to CE. Therefore, you can say PE is parallel to AQ and FQ is parallel to CP. Now we will consider the triangle ABQ. Triangle ABQ. We have E as the midpoint given. Then PE is parallel to AQ. Therefore, P is a midpoint. So you can say BP equal to PQ. Now in triangle PDC, F is we have F is the midpoint is given. Yes, F is the midpoint and F is the midpoint and FQ is parallel to CP. Therefore, you can say Q is the midpoint of PD. So that means you can say PQ equal to QD. So from this you can write BP equal to PQ equal to QD. So that's what we have to prove. The diagonal is trisected by the other two lines. Coming to the next question, given ABCD is a trapezium. In a trapezium, you know, only one pair of sides are parallel. So here AB is parallel to CD and E is the midpoint of AD is given, and it's also given EF is parallel to CD. So EF is parallel to CD means, suppose I am giving this value, this point as G, EG is parallel to CD and FG is parallel to AB. All the three lines are parallel. Now we will consider the triangle ADC. E is the midpoint given and EG is parallel to CD. E is also given. Therefore, G is the midpoint of AC. Also, you can say EG is equal to half of CD. Now coming to the next triangle ABC, in triangle ABC, now we have proved G is the midpoint and FG is parallel to AB. Therefore, you can say F is the midpoint of BC and also FG is equal to half of AB. So, the reason midpoint theorem. Here also you will write the midpoint theorem reason. So, now we have this, let me put this number as 3. Now, you have to find the length of EF. So, EF is equal to EG plus GF. Refer the diagram, EG plus GF. So, EG equal to half of CD plus GF is half of AB from 2 and 3. So, this is equal to half into AB plus CD. We had to prove this also, F is the midpoint of BC also, and EF is equal to half of AB plus CD.